Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we proceed with lecture 12, that is digital modulation radio. So today motivational quote is, Allah does not intend to make difficulty for you, but He intends to purify you and complete His favor upon what you may be grateful. From Surah Al-Ma'idah, verse 6. Okay, before we proceed with to the lecture, okay, let's overview what you have learned before. So for engineering communication, modulation is very important to transmit signal from one point to another point. And for modulation, there are three main categories of modulation. That is, we can divide based on the type of the signals. That is, the first is analog modulation, pulse modulation, and the third one is digital modulation. Okay, you have learned about analog modulation, that we have amplitude modulation. We have double sideband full carrier, double sideband suppressed carrier, single sideband suppressed carrier, and vertical sideband. And for frequency modulation, you have wideband frequency modulation, narrowband frequency modulation, and you also have phi for the phase. So for analog, so actually it is from the V equal to A cos omega plus theta. So this amplitude, and amplitude modulation will affect the A, and for frequency modulation will affect the frequency here omega, and phase modulation will affect the theta. Okay, and then we have pulse modulation. Okay, for the pulse modulation, there are, okay, what is the difference between, okay, there are analog, pulse, and digital. Okay, for analog and digital, okay, the carrier is analog and digital. Okay, maybe I can divide here, analog, digital, and pulse. Okay, for analog and digital, the carrier is analog signal. But for the pulse, the carrier is pulse signal. And then for the message signal, for the analog, the message signal also analog. But for digital, the message signal is digital. And for pulse, the message signal analog. Okay, so this is the basic fundamental that you need to understand, the difference between these three categories. Okay, and then there are in the pulse, because the carrier, okay, and then the message signal can be analog and digital. So this analog and digital is based on the message signal. For the pulse modulation in PCM, we need to do the sampling and quantization. That if we have the analog signal, we need to change into digital to do the pulse code modulation. So this is the analog and pulse modulation that you have learned before, and today we focus on digital modulation. That we have ASK for amplitude shift keying, and FSK frequency shift keying, and PSK is phase shift keying. As an introduction, pulse signal from the previous modulation or coding method normally are not transmitted in their original form. Okay, this refer to the pulse modulation. Because for the pulse modulation, they will modulate a carrier that suitable with the channel used. Because in the pulse modulation also there are many noise in the quantization, so it's not transmitted in their original form, and pulse cannot travel through wireless or free space. uh, okay, this is one of the disadvantage of pulse signal, because it cannot travel through wireless or free space. Therefore digital modulation is better, because in digital modulation it can be transmitted through free space if the analog carrier signal is used. So the important is the carrier signal. So if we use analog carrier signal, so it can be transmitted through free space. And in digital modulation, the signal information is digital signal, while the carrier is high frequency. Okay, this is the definition of digital modulation, where the signal information is digital signal. So the message signal is digital, and the carrier is the analog with high frequency sinusoidal. And this digital modulation is used to transfer a bit stream of an analog channel at high frequency. This modulation technique is similar to the analog modulation, in which the modulating signal will vary the amplitude, frequency, or phase of the carrier signal. Okay, like before, we have when we revise back what you have learned in analog modulation. So you have, for example, you have message signal with low frequency, and you have carrier signal with high frequency. So this which the modulating is the result. This is modulating signal. Modulating signal will vary the amplitude, frequency, or phase of the carrier signal. So we have carrier here, and this carrier will change based on the amplitude, frequency, or phase of the carrier signal. And the only difference is that the modulating signal is in digital signal. So before this, this is the example of amplitude. But for digital, this modulating is in digital signal. In digital communication, the modulating process involves switching or keying the amplitude, frequency, keying the amplitude, frequency, or phase of the carrier according with the input data. And depending on whether the carrier signal is varied according with the digital message signal, there are three techniques of digital modulation called ASK, amplitude shift keying, FSK, frequency shift keying, and PSK, phase shift keying. Okay, like I explained before, there are three. And okay, for example here, you have the digital message signal. Okay, digital mean 10110 something like that. Okay, like here, 1010, and then you have carrier signal. There are high frequency sinusoidal signal. And for the ASK, amplitude shift keying, the message signal changes the carrier amplitude. So this is the okay, we have carrier here and digital. So the high frequency, that's it, the high frequency refer to 1 and high amplitude refer to 1 and low amplitude refer to 0. So the amplitude is changed. And for frequency shift keying, the message signal changes the carrier frequency. Okay, this one, the 1 refer to high frequency and 0 to low frequency. Okay, for the phase shift keying, the message signal changes the carrier phase. Okay, phase is okay, for example here we have, okay, you focus at this. Okay, we have for example, cos theta, and then here is cos theta plus okay, there is the changes of phase there.